Welcome to this video lecture on the topic wave equation for the uniform plane waves and its applications. So first of all, let's discuss what is uniform plane wave. So generally an electromagnetic wave originates from a point in a free space and spreads out uniformly in all directions, and it forms a spherical wavefront. So an observer at a large distance from the source is able to observe only a small part of the wave, and the wave appears to him as a plane wave. So for such plane wave, the electric field and magnetic field are perpendicular to each other and to the direction of propagation. So the uniform plane wave is one in which E and H lie in a plane and have the same value everywhere in that plane at any fixed instant. So for a uniform plane wave traveling in the z direction, the space variations of E and H are zero over a z constant plane. So this implies the fields have neither x nor y dependence. So dou by dou x and dou by dou y are zero. So this uniform plane wave is transverse in nature. So that is E and H are both perpendicular to the direction of propagation. So they are called as transverse electromagnetic waves or TEM waves. So in a uniform plane wave, E and H lie in a plane and have the same value everywhere in that plane. So here in this diagram, a wave of this type with both E and H transverse to the direction of propagation is called as a transverse electromagnetic wave. So, assume that a plane wave is traveling in the direction of x-axis. The electric field has only a component Ey in the y direction, and the magnetic field H only a component Hz in the z direction. So this wave is polarized in the y direction or vertically polarized. So since we are dealing with non-conducting medium, the conduction current is zero. So Maxwell's from Ampere's law is reduced to del cross H equal to dou by dou T of D. So using the rectangular coordinates, we can write for dou by dou t of d is expanded in rectangular coordinates, and for a plane wave traveling in x direction, the only component that contribute are dou hx by dou x equal to y into dou dy by dou t. So therefore dou hx by dou x equal to minus epsilon into dou ey by dou t. So Maxwell's equation from Faraday's law is del cross A equal to minus dou B by dou T. From this we can expand in a rectangular coordinate. So in this diagram we can see the wave travels in x direction. The H components is in z direction and y component is electric field. So these are the field components of a plane wave. So from this, for a plane wave traveling in x direction, the only component of previous one that contributes are x into dou ey by dou x equal to minus dou bx by dou t. So from this we are deriving the wave equation. So for the space derivative of hx to the time derivative of ey, so we can find dou by dou t of dou hx by dou x equal to minus epsilon into dou squared ey by dou t squared. So we are dividing the previous equation by minus mu. So this equation where we differentiate with respect to x and then with respect to t or vice versa. So dou squared ey by dou t squared equal to minus 1 by mu epsilon into dou squared ey by dou x squared. So this relates the space and time variation of scalar magnitude of ey of the electric field intensity and is called the wave equation of ey. The scalar wave equation, it is also known as the scalar wave equation. And for magnetic field, dou square hz by dou t squared equal to 1 by mu epsilon dou square hx by dou x squared. So, and these two equations are important in electromagnetic wave propagation, and it's sometimes called as D'Alembert equation. Now introduce quantity V as V squared equal to 1 by mu epsilon, where V is the velocity of electromagnetic wave. So the equation is modified as dou squared Ey by dou t squared equal to V squared dou squared Ey by dou x squared. So this relation is useful in the studying the wave propagation or a plane wave propagation in different mediums like for conductor, dielectric and free space medium. So dimensionally it is volts per meter square. So V is meters per second. So this velocity is a characteristics of the medium. So it depends on the constant mu and epsilon for the medium. So mu is the permeability and epsilon is the permittivity. For a free space, the velocity of electromagnetic waves, we know that 3 into 10 power 8 meters per second or 300 meha, the value is given. So uniform plane wave is a very idealized case. It can adequately model many practical situations in wireless communications, radars, etc. So fields impinging on receiving antennas that are far away from transmitting antennas are practically uniform plane waves. So these are the assessment questions. So what are the properties of uniform plane waves? So the plane waves have two components E and H, which are perpendicular to each other and to the direction of propagation, have the same value at every point. So what is the D'Alembert's wave equation? So and what is the importance of uniform plane waves? So these are all used in antennas, wireless communication and radar systems. So thank you for listening this lecture.